Hi, welcome again. I hope you got your beverage of choice. I've got my cup of coffee. And what we'll do, we'll start the session. And just before I do that, we've got some great questions coming up. Yeah, brilliant. There you go. So the sessions will be available to you. All these sessions are recorded and they'll be available once the whole series is completed, which today's the last one. And you'll get a link to all the videos and content as well. Anything else? Feedback, please use the feedback form when you get the chance, because we want to continue this webinar series. We want to continue to kind of show everybody the love of what BricsCAD can offer folks out there. So please, it takes literally less than a minute, probably less than that. At the end of the day, we're doing these webinars for you. Again, use the Q&A little tab, which is on that side, sorry. Ask any questions you like, purely because we can monitor them. And if we do miss you on the chat, because I can see the chat is just going to go quite fast. Again, we've got somebody from the UK there. Dale, excellent. Glad you're joining us. Love it. So yeah, please use the Q&A tab for that. Okay, so what we'll do now, let us start the session. So hi and welcome again to the BricsCAD Unwrapped series. You know, discover BricsCAD as the new trendsetter in the CAD industry. It really is a unique opportunity for anybody joining in, because what we're doing is we're unwrapping BricsCAD and delivering to you and showing you what what gaps it can bridge in your organization. It is such a great session. And you know what, even if you're an architect, designer, surveyor, interior designer, a CAD user, someone's using Bim, BricsCAD is for you. And we've had some great sessions, and the final session is going to be even greater. And just to make sure for those people who have joined, we are officially on session 5, the final and last of the series. It's, as I said, it's going to be emotional. It's been the team and it's been great doing this. I think I can see from the chat window, it's absolutely phenomenal. Keep the chat window going, folks. Let us know what you think. And yeah, it's going to be, and we say the best for last, by the way. Fleur's renowned for a demonstration. It's going to be amazing. So, stay tuned for that. I cannot stress the point. As I mentioned, so today is all about BricsCAD Ultimate, which is literally, what we like to call the all-in-one CAD workflow. But again, for those coming from the previous sessions, we welcome you back. For those just joining in, we thank you for joining in. Again, these sessions will be recorded. And it's going to be a great session. As I said at the start, my talk track, I've kind of reduced that today to give you the best. There's so much in BricsCAD Ultimate, and even then, we only got to scratch the surface. I want to make sure I shut up now, and then we'll give more time for Fleur. So I mentioned Fleur quite a few times now. So let me now introduce you our host. So we've got the talented Fleur Dooms. There she is, based in Ghent, absolutely passionate in what she does, absolutely great, one of our great BricsCAD Bim product specialist from my head office, and myself from the UK. Okay, so let us now, I'm just going to turn off the cameras as we always do, and we'll continue the presentation. So, BricsCAD is unique, it's innovative and cost effective. Again, based on DWG CAD platform. So regardless of what you're using today, folks, if you're coming from, 2D, 3D, maybe doing a bit of BIM, bit of mechanical design, we've got it all. We cover all of the 2D, 3D, mechanical, and BIM in one application, and that's BricsCAD Ultimate. That's what you get with a 30-day trial. And one of my colleagues will send the link in the chat window. That 30-day trial is for yours. That's yours to use. If you need longer time, let us know. But that's for you. Please check it out. It's a great solution. It really is. It's the all-in-one, great for your workflows, multidisciplines. Yeah. So, I briefly mentioned Bricsys. So who are we? Now, Bricsys is the company that makes BricsCAD. It's a global provider of affordable, modern CAD, BIM, mechanical CAD, and CD environments, brought to the market under the BricsCAD and Bricsys 24/7 brand. We are part of Hexagon AB, And, you know, I always say this to folks that BricsCAD is our best kept CAD secret, but that's changing as new customers are embracing BricsCAD now with over 300,000 active users in over 110 countries. And by the way, that number is growing at a very fast rate. We celebrated your 20th birthday in March this year, headquartered in the beautiful city, absolutely gorgeous, in Ghent in Belgium. And if you look at some of our customers, you know, that BricsCAD service, you know, we service various types of industries across the globe, and that footprint is expanding. And this is just, you know, a sample of a customer base for those who are fed up with license changes and lack of development in the current CAD software. You know, we literally got it all. So let me formally introduce you now to BricsCAD Ultimate. I've kept it very short on the slide because for me, it's the all-in-one solution for continuous workflows. You know, for designers, engineers, manufacturers, and contractors. It really does bring our CAD and BIM solutions together in one bundle. So multidisciplinary organizations can benefit from a continuously developing workflow to work better together. One platform, move from concept to creation, all the tools you need to design, build, and manufacture, one platform, BricsCAD Ultimate. For compatibility, you can improve productivity and remove errors with a single DWG file format. Okay, it's all based on DWG. And with BricsCAD Ultimate, you do gain access to the full suite, the full suite of BricsCAD solutions to meet your design needs within one multi-purpose CAD platform. We covered all these from session 1, 2, 3, and 4, where we took you and we showed you and demonstrated the benefits of using BricsCAD Lite for 2D, BricsCAD Plus for 2D and 3D, and so much more. Mechanical and BIM, that's all available in Ultimate. And remember, folks, it's one application. No more switching different applications. It's one application, just different environments, depending on the license type. So what does BricsCAD Ultimate look like? Now, BricsCAD Ultimate is affordable. I mean, if you just look at a low entry, always up-to-date subscription price, just over £1,000 for BricsCAD Ultimate. If you would like to own your license, buy once and own it forever, just shy of, just £1,900. And again, both of these, we do support network, multi-user, volume, or single user options as well. And as a side note, if you're a developer or work in education, we want to hear from you. Let us know, request for more information, because for you, it's free. So do, reach out. Now, these prices are great, but if we then compare that to, the all-in-one CAD with its all-in-one price, and you can see the saving up to 60%. I apologize, we've got an international audience today, but because we're on base, I've kind of based this on sterling, the old great British pound. But you can see, the saving, BricsCAD Lite with Pro and BIM and Mechanical. Ultimate really is. I mean, I was just speaking to a customer, which I won't name because we haven't got the permission, just a few weeks back, and they had 20 seats of AutoCAD just to do 2D drawings, 5 seats of a 3D CAD application. It was a mixture of SolidWorks and Inventor. Don't ask me why. I've never seen them two sitting in the same business, but they're just different departments. Well, they're using BricsCAD Ultimate now. And instead of, just swapping out the AutoCAD licenses, what we were able to do, we were able to give every single user BricsCAD Ultimate because the price, and it was, I kid you not, folks, it was less than half than what they were paying. And they get one application, one solution that covers all their needs, 2D, 3D, BIM, and mechanical design. And if they wanted to, they could have network options as well. So I did say, folks, my bit's going to be short because the demo is going to be phenomenal. It really is. It really is. I can see some questions coming up. Please keep them going. Keep the chat window going. Let me know how you're feeling. Let us know how you're getting on. But what I'm going to do now is I'm going to hand over to Fleur now for the fabulous demonstration of BricsCAD Ultimate. Fleur, the floor is all yours.
Well, thank you, Jess. So indeed, we are now gonna see a webinar of Ultimate. So we are in the webinar of Ultimate, which means that I'm gonna give a demonstration of BricsCAD Ultimate. BricsCAD Ultimate is both mechanical design and BIM, as well as 2D and 3D drafting combined. So if you have the launcher, it will look like this. And we can start off into the BIM workspace because we will do a scan to renovation project, scan to BIM to renovation, and then from the renovation to assembly. That's what we are gonna do with a row house somewhere in Belgium. And more specifically, we are gonna renovate the garage into a new study room with some extra elements. So we can first open our starter file, which is just an empty file, but it's already so that I can show you quickly the point clouds. So in point clouds, we have the settings. We have a lot of extra commands if you have BricsCAD BIM. So one of the commands you also already have in Pro, but which is of course possible in BricsCAD BIM, is the pre-processing of a new scan. You can click the plus button here to do that, or you can insert like I'm gonna do now. Inserting is just like you're inserting an XREF, and then you can see that the image immediately disappears. As I zoom, more pixels are rendered. As I zoom, less pixels are rendered while I'm zooming, and when I'm zoomed, more pixels are rendered on screen. And we always have a fixed amount of pixels on screen so that you can quickly process even large point clouds. Then we can see some features, which is increasing the points so that they are better visible, maybe coloring them to the elevation, or maybe resetting the colors to the scan. And then we can also go and align the point cloud. For this, we will be redirected to a top view because it's needed to select a rectangle in top view. And here you will see that the point cloud is still rotated. If I align the point cloud based on a selection that contains a lot of XY aligned walls, you will see that the point cloud aligns itself, which is better to work with afterwards. Then we can also crop the point cloud either with crop solids or with just our regular crop tool. And then we can leave, for example, only the inside visible or only the outside. So what I want to show you as well is detect floors. Detect floors will detect all the floors in a point cloud, and here it found 2 floors, and now I can quickly clip through them just below the ceilings. And then especially in BricsCAD BIM, we have a feature which is the bubble views. If you have a structure point cloud, you can open the bubble views. Those are the green bubbles. If you don't want to display that, you can change that in the properties of your point cloud. But here, if I double click on a bubble view, you will see the scan position from where the scan was made. And from here we can launch Fit Planner. Note that the Fit Planner is a command that is special to BricsCAD, and it allows to detect walls as is by finding a plane of common points inside your drawing. And you can do this if you launch it from Bubble View. You are expected to pick a point in Bubble View. And you can, for example, pick the ceiling of this, or maybe not the ceiling, but here the wall. And then you will see that a plane is immediately created corresponding to to have as less outliers as possible. outlying points. So that's one thing, but if you now hold down shift, you can quickly trace over the entire room. And by holding down shift, you are actually stitching all the surfaces in the room together. Well, we're not stitching them together, we're like making sure that they are nicely connected. And as soon as I have all the faces of the room selected, I can select the opening still. So here we can detect a rectangle that will denote the opening in the point cloud. So you see that here a rectangle was made, and we can do the same for the other side, like that. And then you can either choose to stitch the surfaces or not. Stitching the surfaces will make sure that they come into one big solid. If you don't stitch them, don't worry, we can do that later, as I will show you now. But for now, just accept the defaults, and you see that now if I hide the point clouds, so I can cancel the command and I can hide the point cloud. And then we see that we created a room solid. Still, the color might need to change a bit so that it's better visible. And we also see the rectangles that were created. If I don't crop my view, then you see that the entire solid of the room is made as is. So the walls are also a bit slanted in this case. Then we can do the same for every room in the house. And once we open the bubble view, we can launch Fit Planner once again. And I can do the same for the next room. So maybe start with the ceiling in this one. Then just go over all the walls that we see, and it will make a suggestion. All right, and then detect the openings with select opening, and then select the door opening still. Okay, and then I can accept and I can cancel the command, and now I will have a 2 rooms, and as you can see, at the moment, they are just faces or surfaces. If we want to stitch everything together, it's best to select all the surfaces and then just call the command dm stitch. And then you will see that now the rooms are actually turned into solid, so you cannot see through them again. So I like to do it at the end. And then what we are now going to do is we're going to skip to a model where all the rooms are made. So I will open a next file of this. So here you see the point cloud with all the walls modeled. But if we look closely, this is just the result from Fit Planner on every room separately. If we look closely, we see that here the slopes aren't exactly 90 degrees. So here maybe it's 87.7 and so on. Now there is a command that can help you optimize this, and it's called just that. It's called Optimize. Optimize is again a BricsCAD specific tool that will rectify your faces or your 2D entities if you would do it on 2D entities. It will rectify them based on the XY, YZ and XZ planes, depending on what you select here. It will make faces that are almost coplanar. It will round off the values of the distances to a rounding precision of 1 millimeter. In this case, you can also select more. You can also add a distance tolerance to determine when two faces are coplanar, and here I will make that only 50, and then so that our interior walls aren't mapped to one face, let's say. And the angle tolerance I'm gonna put a bit higher because we have quite some slanted roofs that I all want to rectify. And then we can press preview and see how it's being rectified. If we're happy, we press OK. And now if I select the same face again, we see that it has a slope of exactly 90 and everything is like nicely coplanar if you would look to the nearest distance, for example. So that's needed for to be able to use the next command, which is back in the point cloud space, is invert spaces. It's literally inverting the spaces so that it becomes the house geometry instead, so the walls and so on. And if we invert the spaces, we can also see some settings. I will leave most of them untouched. You can erase your input solids in this case. It's a bit easier so that you can immediately see the result. And then here we can create a single wall shell, which makes sure that, and we can slice this single shell into per floor and split it into separate pieces so that it becomes ready to use as a BIM model later on. So I will click apply, and here you will see the values, the thicknesses that weren't specified just by having adjacent rooms. So the outside shell, let's say, and then I will just press apply and you will see what the algorithm does. It kind of makes sure that the spaces are inverted and everything stays as you wish. So yeah, you might need to do some direct modeling to clean up this side, for example, and maybe do some more direct modeling with push-pull to make sure that it's more like an actual building would be built. So you can direct model as much as you want. But you can see that the elements are already nicely created. Now note that normally invert spaces will also already give you the BIM properties, so it will already classify the slabs into slabs, the walls into walls, as you can see here. But for the sake of this demonstration, I will use an unclassified model and classify it from scratch a bit later on, because we also still had our rectangles that I can show again. Here, the openings that we created before. Now note that these will not be rectified together, so you will need to project them with project geometry command onto the surfaces of the walls, and you can use some perpendicular E-snap to quickly get the job done. So I will say here, I will just go from the corner of the rectangle to the perpendicular plane, and then you will see that as soon as I have that, I can actually highlight the boundary of this rectangle, so of this inside this opening, and then I will be able to create a window. But let's see how the window looked again. So as I can see here in the point cloud, it has like a 3 panels. So I will recreate that by using the tool that's called create window with the option style of 3 panels. And now I can still change the parameters to fit my designs better. For example, if we want a very small window, but here it was approximately like this, I think. So yeah, that's how we can trace over our components, and we can also insert some components like the doors from the component library, and then we can base the parameters on our polyline. So here we can go to doors, insert the door, and then change the parameters so that it fits this frame nicely. So we can then go here and see what this distance is. So it's 740, and then we can give this distance here in the width. Okay, and then our width is already approximately what we want. And as such, you can trace over your point cloud. You can do this for all your openings you created, but of course we will not wait for that, and we will just go further with the next prepared drawing, which has all these components already inserted. So if you look closely and I hide the point cloud, you will see that all my doors, there's a stair. But as I said, maybe your classifications weren't correct right away, or maybe you added some extra geometry. Well, now we are gonna use Bimify. Bimify is a BricsCAD specific tool, once again, that allows you to convert dumb geometry into smart geometry, into Bim geometry. So that's where we will go. So here we will also see that you can classify anything as anything in BricsCAD. So you can, for example, first select these two solids already, the roof solids, and then you can classify them as roofs. That's one way to go. Or you could do that after Bimify if Bimify would have made a mistake, for example. But if you do it before Bimify, then Bimify will not overrule this. So that's very convenient. If I now launch Bimify here, maybe I show my structure browser first so you believe me that they are just 3D solid, except the two roof panels which I already classified. So if I now do Bimify, you will see all the options. I will not create sections this time because I already have the sections that I need. And then I apply everything, and yeah, you didn't see it right now because I didn't keep the panel open, but here you will see that now we have all elements classified and assigned to spatial locations. So if we orbit a bit to the side, you will see, okay, floor 0 looks pretty good. Floor 1 also looks pretty good. Floor 2 also looks pretty good. The roofs which we classified before, still roofs. Nice. Then if we look into a bit more, like we see the walls, we see the slab, we see even a beam. Same for the lower levels. We see the doors, we see the windows. Everything goes classified just from dumb geometry, just from block graphs and 3D solids. Okay, so that's pretty nice. I hope you also enjoyed that. And then what we can do, of course, is check if all the properties are correct. We can also here set some extra properties like the name. We can easily have defined different grouping types in the structure browser. And there I can, for example, select all my walls and I could give them the name wall, or you could specify the outer walls versus the inner walls, or give them a coding name depending on what you like. Okay. Then finally, I already added some more information into the then also what we can do is add some compositions. So here I can filter by composition, but if there is no composition, I filter by thickness of the walls. And here you see we have some 100 walls, but also we have lots of different values that are almost 100 millimeters. So what we can do is we can define a composition. So we open the composition dialog. We choose, for example, the drywall. We copy that one to our project, and we say that this one is the one with 100 millimeter thickness. and we change some of the thicknesses of each layer. So for example, you can change here to sorry, 76, I think it's, yeah. And then we see that the entire thickness is now exactly 100. What does it mean if all the locks are on? It means that your thickness that you had before will be matched to exactly 100, and normally the walls, well, they stay nicely connected if possible. So here, for example, this L connection will be maintained. We can show you that by now going to only our compositions in our project and applying the drywall composition. You need to select the reference face from which it applies these compositions. And then you can see that the L connection is maintained as good as possible, but we might need to L connect once again to clean up the corner. Same here. So as such, you can easily make sure that all your compositions are correct. And it might not look like much, but actually we have here a composition attached. And if you look closely, we also have some, if we put on the level of detail, we also have the different plies here. So that's very interesting. We could use auto match to automatically, if you have every one example of everything, you can use auto match to automatically make the entire drawing according to your compositions. But here I did it just by selecting the correct thicknesses from the structure browser and applying the composition that I made to it, so that it becomes all clear and correct thicknesses. And I did that in this drawing. So here we will see the entire drawing where some compositions have been made. And you will see that now not everything is looking as I would wish it. So for example, if I look here, my level of detail isn't that great yet because my bottom is not, like it's not structurally sound. My structural element is not connected to my concrete slab. So I can still change that. If composition level of detail is on, you can push-pull certain layers. And then we can propagate this element to different locations. So I select both solids, and then I select no base solid for now. And then I see, okay, these two walls will be propagated to, or this connection will be propagated to other locations where exactly this type of wall and exactly this type of slab is also found. And as you will see now, it's not in that many locations. We can see it's just in a few locations of the same wall, basically. So you could accept this, but I will cancel it because we have a far more interesting element, which is the details panel. In the details panel, you can actually store your details. So while you did propagate, you also had the option to save your detail to the library. That's what I did. And then you will find a similar connection here. So the wall slab connection. And then here you will see that I have this inner wall. And then I can click Parameterize to parameterize this detail. And then actually everything will be parameterized. And the entire detail will be mappable to locations with exactly the same amount of plies in their compositions, but with varying thicknesses of the plies. So the only prerequisite of finding a similar location is the amount of plies. Material thickness of the ply doesn't really matter. And if we have parameterized it, it's just like this one here. You can see that we have some tolerances. The angular tolerance is how tilted the wall can be. The thickness tolerance is how thick of a varying thickness we can map it onto. And then let's just see it in action. So first of all, note that here none of the walls have been done yet. Then I can just drag and drop my detail in there and it will calculate for me all the locations. So maybe I don't want it at these locations here. So yeah, I don't want it here at my toilet, but I want it in all the other rooms. So I say apply and let's see what happens. The detail was applied to every other location. Note that also we had some extra details in this parameterized detail, which also has baseboards. So as such, you can easily propagate baseboards all the way into your entire drawing. And you see that here was also made. But if we will look and move our section a bit, then we will see that in the area of the toilet, the details were not applied. So that's super great. And then it's time to show you the final BIM model result. So it's an as-built model where I have also attached a thin surface for the front garden, or how do you say that? And then here I can show it to you in the attachments panel. Yes. So this is the entire model with the garage also modeled and so on. Then I can hide my point cloud. You see the model is very nicely detailed. Also, if we look through the cut through section, all our details are modeled as I would wish them. There are baseboards everywhere. Everything is classified nicely. So we're very happy at this point. I just want to show you that you can also use civil surfaces, so thin surfaces from BricsCAD Pro in BIM models. So you can reload yeah, and then you can see that the thin surface is now attached. So it's a bit faint, but that's a setting. And here you can see even the pavement is visible in the thin surface. So it gives you an idea of how the surface terrain is going outside. To make the sections, it's best to unload your thin surface, otherwise it might take a little bit of time. So here we have now a BIM project really with some information such as our company logo, our project name, and so on. We have, of course, some sheets. These sheets correspond with here the section objects that I have in my drawing. And then we here see all the sections and all the files that are in our project. So let us open a sheet. And then you can see that I also used point cloud project section to give like a nicer infilling of my room based on my point cloud. So the point cloud, it gets turned into a raster image from that section plane. And then it allows you to see, for example, the furniture, where the furniture is placed, even though I didn't even model the furniture. And then we can also open a cross section here. So here we have our cross section with nice details. So we can, of course, annotate some things such as the tag composition. You can tag a composition. Oh yeah, okay, maybe that's actually okay. So you can tag a composition here. That's one element. That's the facing bricks. But you can also say, okay, we need the entire, because this is like just the pillar at the end, which is only existing out of facing bricks, but here our entire layout of our wall is given, maybe also from our floor. Maybe do some spot elevations on the stair. So we say, okay, this one is that high, but maybe also here we see the spot elevation of the outside, and here of the floor. You can of course also dimension some things, such as here the height of the beam, or all your walls and so on. We also have a new command, Bim Dimension, which is possible to use on top of our generated sections. Okay, so that is our scan to BIM, but now our renovation part still. We want to open our master file once again, but I just made a copy so I can do some renovation work in here. Basically, I want to renovate this garage shed in the front. So I delete or put these elements on the status. You can put them on the status demolish, for example, to make sure that these components are going to be demolished. But for now, let's keep it simple and just delete the elements. And then, or maybe just the components, so that we can see the wall still. So now we have just a plain single layer brick wall, if you turn on the compositions. But we can also make sure that it's a new composition, such as the engineered wall, so a wooden frame wall. And then we can see how it would look. We can maybe design some BIM grids just for you to see. So I will start here. I will say 0.5 onto 0.8 maybe. Okay, and then I have my grid. Then we can move this block a little bit. And then I can make a window out of this grid. And I can delete the grid afterwards, so that it becomes nicely a nice model. And here for the garage door, I have a very special request. I want to have a special garage door, which is also gonna make a shading. And for this, I will turn to my renovated house, where I already prepared this. So you will be able to see what I mean in just a bit. So here we have actually attached a grasshopper file to a 3D solid. So I can, for a second, hide the point cloud, and then you see actually what type of garage door I want. I want like a garage door which has these shading elements that also turn into the garage door panels. And we can change this entire thing, because it's now just a Grasshopper script. If you have the Grasshopper plugin, you can also clear the data, and then it will turn back into a regular geometry. But if I attach the Grasshopper script again, then you will see how it looks if I close the entire door, and then you can still rotate, for example, only your panels 45 degrees, or maybe the entire shading with 90 degrees. And this is like the type of garage door I imagine, just a pre-design very roughly. But now we want to fabricate this, of course, because this is an ultimate webinar. So we are going to do design to fabrication. So how am I going to do that? Well, I can bake these grasshopper elements, and I can actually just start off from there. So I can clear the grasshopper data on this element so that we only see our baked elements. So this is my pre-design. I hope you also agree that it looks kind of fancy. I will want that as a garage door. And then what I can do is I can actually, yeah, maybe it's better if I bake it also when it's closed, of course. Then it will be a bit easier to model with. So I just undid a few steps. I'm gonna bake everything and then clear the grasshopper data from this element and delete that element. Yes, and then I see my garage door, which is closed, which will be a bit easier to work off. But note that if we classified elements into our grasshopper script, this will also become here the correct classification type, and you can define this into your grasshopper script. So for example, here the framings I made members. So yeah, that's a cool trick from Grasshopper. But here, let us take this assembly and just copy it to a new drawing. So let's start in a mechanical template now. Oops, that was the default template. Mechanical, yes. All right, let me just change my background. Okay, so we have here a new drawing, and I can copy paste my block there. Now it's maybe better to move it so that this becomes our 0, 0, 0 point. Yes, and then we can actually start by transforming this into an assembly. So how will I do that? Well, it's actually quite simple. First of all, I will delete the repeated panels. Then, you could also use parametric blockify for this to find all the parametric blocks and define them all into one type of block. But here I choose to just start off from the bottom beam and then block everything. But first, let me change this so that I can parameterize this entire beam. So first I will switch to the mechanical space, and then I'm gonna go to, yeah, as you can see, nothing is parameterized right now. But if I go to auto parameterize, you will see that these elements, they get parameterized. We can delete the fixed constraints for now. And then we can see that we can actually animate this length, for example. So now it became parametric. We can then BM form this or block it just. If you block it, it will become a parametric block. If you BM form it, it will become a component. So we can actually say that this is the panel. And then here we can say that this is a block reference. So this is not an assembly yet because it's just a block reference, and block references, yeah, actually assemblies need components with a little bit more of information, but we will see how we can turn blocks into components later on. So here I will do the same. I will auto parameterize, delete the fixed constraints, block it to inner frame, pick on screen. Yes, so we now have here a block reference again, and I will do the same for the last frame, the outer frame. Okay, and then I will block it to outer frame. Okay, and now I have actually something which is not yet an assembly. It's just yeah, it's just some block references. How do I make an assembly out of it? Well, very easy. You go to assembly and you say initialize mechanical structure. If you have a drawing with blocks and blocks and blocks, or it will initialize a mechanical structure right from it. So you can convert all the blocks into components, and then you see this little icon change, but you also see that now we have a component with some extra data to it. And then we can, of course, link all the parameters so that they are controllable from the outer element. So now we can say length X. You can see, oops, that was a bit difficult. You can see what changes here. And then finally, you can have actually an assembly that's entirely parameterized. But that's not enough for me. I just want to create this. Well, of course, you could repeat this, array this block upwards first, of course. I didn't do this now. But that's just a matter of an array command. But before I do that, I will show you that I can also turn this panel into a sheet metal panel. And for that, I will actually start from a 2D drawing this time. So here I will say the 2D drawing. And then I can actually very quickly extrude my polyline so that it becomes a beam. And then from here, I can turn that into sheet metal. So it's very easy. You convert to sheet metal your flat element. You say entire model. And then here, my entire model is now sheet metal, but it's not really fabricatable as it doesn't have bends yet and so on. But also that is very easy. You say create bends on entire model, and we have all our bends that we need. But let me switch to where I also have a 3D model of something which is almost sheet metal, but not quite yet because it doesn't have this blue color yet. So you can also convert something which is already entirely fabricatable, maybe made in another program, imported through STL, whatever. You can turn it into sheet metal in BricsCAD. And the power of sheet metal in BricsCAD is that you can unfold your body. So you can actually make an unfolding very, very easily. And then you can see how that turns out with all the bend radiuses applied and so on. And then finally, I added some extra elements here that made sure like I added these holes, but as you can see, I added something else. I added parameters. So here you can also do this, but you will probably need to add some extra manual constraints. But if you go to the sheet metal tab, you have here sheet metal parameterize on the entire model. And then you can see that actually from now on, we can control the overall length, for example, very easily, because the entire sheet metal part is actually parameterized right now. Maybe you will need some extra constraint placement if you have complicated parts, but in general this does a good base for you. And then we can have something like this where we can animate the entire length, the entire height of the elements. Our holes move along. We can animate the thickness. And why is this so important? Well, at this point, if I can actually replace my my assembly with so I will open this assembly. So I can have my assembly, and I can replace this. That was not the one we were working on before, but just allow me to initialize the mechanical structure here once again. So here we have all the panel again with all the parameters, so we can link to parameter once again. And then we can actually replace from a file, and then we can replace from the sheet metal part which we just created. And then you see that all the parameters, although my sheet metal part, it was way shorter, all the parameters will be applied. And it will be reapplied. It will look as I desire. And then finally, as I said, we can array this first panel upwards. And then if you put a little bit more effort into it, you can even make an entirely an entire parametric assembly. And with this parametric assembly, you can actually make bill of materials, you can make layouts from it, and I will show you the result now. So here we see that we have some parameters. The ones with green will be visible when we insert it. So for example, the outer height is completely parametric now. This is because the tolerance value is too short. So here you can see that we can also change the amount of panels, but later we will see this in action in our BIM model, because that's of course the final step, return this component, this mechanical assembly to our sheet metal part. But first, let us see how the layouts were created for this file. So here we have a small bill of materials with every component annotated. We have a front view, side view, cut through section view, then some exploded views. We have some annotation bubbles that apparently lost their icon here. So maybe we can reapply the balloons. So we select this viewport and we select our number bubbles, and then they now are back on their spots. So easy as that, you can annotate your mechanical drawings. You can also find a bill of materials here, where we can go to a bottom level where we, for example, see everything just up until the mass of the inner frame, the outer frame, the materials of the inner frame, the volumes, everything you need to know, you can add it into your assembly drawing. And then finally, let's go back to our renovated model. We can stay in the mechanical workspace or go back to the BIM workspace. And then with the command bm insert, you can now insert the final garage door. Yes, and then we can place it as such. Okay, and then we now have our final component, which is fully parametric, where we can give, for example, only 8 panels. Or change the lengths and so on. Okay. So that concludes the entire webinar. You can, of course, also make some extra types plans for your renovated building. And then finally, I will hand it back over to Jess for the Q&A. So feel free to shoot your questions.
Excellent. Thanks, Flo. What a fabulous demonstration. I don't know about you folks, but I want to know where you can get that garage door. I kind of like it. I really do. I did say it was going to be a jam-packed session on the demo, hence why I kept my bit short. And as promised, I'll continue to keep my bit short. We'll move straight to the customer stories. Customers, folks who have taken advantage of BricsCAD Ultimate. The first one I want to talk about is Bastien van der Steen, who's a very busy, versatile entrepreneur in the real estate world. He's involved in so much more than just buying and selling properties. The company IQTA, they're developing multiple projects based on synchronized construction, like temporary housing using high quality design containers. And they're based in the Netherlands, and they're using BricsCAD Ultimate, and they enjoy the BricsCAD package with BIM and the mechanical functionality, exactly what Fleur demonstrated, that all in one CAD solution, to support system construction and regular project development. Again, this is a great story, and we see this more and more. Folks who've got different versions, different applications of 2D, of also different applications of 3D, and they might even have some BIM. They might even have collections. Really check out BricsCAD Ultimate. I kid you not, you'll be amazed. Prototype. Let's talk about Prototype. Again, based in Bulgaria, and 85 engineers. They work alongside architects to create the facades for some incredible buildings around the world. Like the Gash Holder triplets in King's Cross in London, UK. The Largo Sofia in Bulgaria, and of course the city center building in the USA, Miami. And a great message from the director there. They really do like the fact that BricsCAD gives his team the power to do 2D, 3D, mechanical design, and BIM in one CAD system, that all-in-one CAD solution that offers flexible licensing. It's what we've been saying, folks. With the BricsCAD Ultimate, that's what it's all about. But there you are, folks. On behalf of the BricsCAD team, we bid you farewell. It's been a great journey. The whole point of this webinar series was to unwrap BricsCAD. We have a lot of folks who use BricsCAD Lite for 2D, BricsCAD Pro for 3D, mechanical for advanced mechanical design, and BIM for building information modeling. And we just want to show that with Ultimate and with the whole series as well, you do get the one solution that bridges those gaps for 2D, 3D, mechanical, and BIM. Now, you could be using BricsCAD Lite or Pro today. You're not going to change software. It's the same software. It's an update of a license, and boom, you get mechanical, BIM, or Ultimate, whatever you choose. So, request for more information over there. We'll get back to you. Thank you for the comment, and thank you for joining. This webinar is for you. Please get the feedback form done. We'll make the next webinar bigger and better.